Amines, classification, structures and uses. Here we are going to see different types of amines, structures of few amines and their applications. Amines. Coming to the definition of amines, these are any organic compounds or functional groups which contain the basic nitrogen atom. Here the nitrogen atom is present with a lone pair of electrons. This lone pair of electrons is present on the sp3 hybridized orbital of nitrogen atom. And we can also give amines as they are formally derivatives of ammonia, wherein one or more hydrogen atoms of ammonia have been replaced by a substituent. That substituent may be either an alkyl moiety or aryl moiety. And next, coming to the basicity, that nitrogen atom which is present in the amine groups is said to have lone pair of electrons in sp3 hybridized orbital, that is resulting in contribution of unshared pair of electrons to form a bond with the any electron deficient species. So it acts as a nucleophile, and thus we can say ammonia or derivatives of ammonia such as amines are said to be basic in nature. And one more point, nitrogen is less electronegative than oxygen. Hence, ammonia is a much stronger base than water and also a much better nucleophile. Next, coming to the classification. Amines are mainly categorized into three types: primary amines, secondary amines, and tertiary amines. Primary amines. Coming to the definition of the primary amine, it is nothing but derivative of ammonia, where in which one of the three hydrogen atoms in ammonia is replaced by either alkyl group or aryl group. And here let us see an example. Ammonia is having formula NH3, where one hydrogen is replaced with R, resulting in RNH2. This is the general formula of primary amines. Example, here we can take aniline, where R represents aromatic moiety and resulting in aniline. Next, secondary amines. Secondary amines have two organic substituents, that is, these are also the derivatives of ammonia, where the two hydrogen atoms of nitrogen are replaced with either alkyl group or aryl group or both. Example, here we have taken N-methyl aniline, where the two substitutions are methyl and aryl moiety, and the general formula here we can represent it as R2NH. Tertiary amines. Tertiary amines, here on the nitrogen, three different substitutions or three similar substitutions are present. That means the three hydrogen atoms of nitrogen on ammonia molecule are replaced with either of the three aryl moiety or alkyl moiety. Here we can take an example of N, N dimethyl aniline, where the three different substitutions like methyl, methyl and phenyl moiety is a substitution. The general formula is R3N. Coming to the nomenclature, few guidelines to be followed. For example, first point, alkyl groups is selected as a basic chain which is followed by naming amine. Example, CH3NH2. Alkyl group here is methyl moiety. To that, the functional group NH2 is attached. So it is said to be methylamine or simply methanamine. Next, if two or more identical groups are attached to the nitrogen, then we usually give prefix di or tri depending on the number of groups. For example, here we have taken an amine with two methyl groups attached. It is a secondary amine, and we usually say it as N, N dimethylamine, as the two methyl groups are attached on the single nitrogen atom. Next, if two or more different alkyl groups are present, we have to follow the alphabetical order. Here we have taken another secondary amine. The two different substitutions are methyl and ethyl. Then follow alphabetical order. It is said to be N-ethyl, N-methyl amine. Next, coming to few other examples, we can take the alkyl chain as a basic chain, and two different functional groups are present, that is amino group and alcohol functional group, and simply we give naming as 3-amino 1-butanol. One more aromatic substitutions, like we have seen basic ring is aniline, and bromine atom is found to be the substitutions at 2, 4, 6 positions. So it is said to be 2, 4, 6 tribromoaniline. And one more example, methyl and ethyl and phenyl substitutions are present on the nitrogen. It is a tertiary amine. We give it as N-ethyl, N-methyl aniline. Next, coming to the structures of few amines. For example, we have taken the first one as ethanolamine. Ethanolamine, its formula is OH CH2CH2 NH2. Here ethanolamine, it is also known as monoethanolamine, and its IUPAC name is 2-amino ethanol, as a basic chain is 2-carbon chain with the two functional groups OH and NH2. So it's said to be 2-amino ethanol. The molecule is bifunctional. Why? Because it is having both a primary amine and a primary alcohol. Its applications are, it is used in the production of detergents, emulsifiers, polishers, and it is also used as a chelating agent in ethylene, like ethylene diamine tetraacetic acid. It is also used for buffering or preparation of emulsions, that is where it is regulating the pH. So it is acting as a pH regulator in cosmetics. And it is also used as an injectable sclerosant in the treatment of symptomatic hemorrhoids. Coming to the next one, that is ethylene diamine. Ethylene diamine, where ethylene group is attached and the two amino groups are present at the two terminals. Its IUPAC name is ethane 1,2 diamine. It is used in large quantities for the production of many industrial chemicals, like it forms derivatives with carboxylic acids, nitriles, alcohols, aldehydes and ketones. It is also a bifunctional nature, having two amines. As it is having two amines, it gets cyclized with organic compounds to form heterocyclic compounds like imidazolidines, where it is a heterocyclic compound having two nitrogens at 1 and 3 position. Next, it is also used as a precursor to chelation agents, drugs and agrochemicals. And it is a main pharmaceutical ingredient in the common bronchodilator drug aminophylline, where it serves to solubilize the active ingredient theophylline. Ethylene diamine has got one more application, that it plays an important role in the formation of polymers, as it is containing two amino groups at the two terminal positions. It can try to form different polymers. For example, it can try form formaldehyde polymers, which are used as plasticizers. Coming to the next amine, amphetamine. Amphetamine here, it is a primary amine. It is having IUPAC name 1-phenyl propane 2-amine. 3-carbon chain, the propane, and here we are having substitution of phenyl moiety on the first carbon. Next, amine functional group. Next, coming to amphetamine, it is a central nervous system stimulant which is used in the treatment of attention deficit hyperactive disorder, narcolepsy, and obesity. Amphetamine was discovered in 1887. It exists as two enantiomers, levoamphetamine and dextroamphetamine. It can also lead to euphoria and it suppresses the appetite, which can lead to weight loss. So like that, here we can see different amines which are having different applications. Amphetamine is mainly used as a CNS stimulant. Thank you.